Welcome back to the Pioneer STEM Show. We have in the building Toby. Toby, what do you have for us today?
Okay, today I'm with Mavic Vision, an AI-powered smart glass for the blind or for the visually impaired. That's
Amazing.
what I have
Can we
today.
see?
Okay. So Mavic Vision is still a prototype, anyways, and we are working to make this a full product after 3D printing the necessary parts. So this is Mavic Vision.
Amazing. Amazing. I have to ask, why are you wearing hand gloves? I'm not wearing one, so.
Oh, okay. The reason why I'm wearing hand gloves is because of this board. This is a Raspberry Pi 4 board and a camera. So some boards, when you hold them with your bare hands, they tend to fry. I call it fry. We call it fry.
Okay.
So fry means you burn the board.
Okay.
Because
so
your hand can conduct kind of the
amazing. Static electricity, is that what it is?
Yes, something like that.
Fantastic. So can you walk me through? I'm seeing so many wires. I'm seeing glue. I'm seeing certain things. Can you walk me through what all of these are, one by one, and how they work?
Soon, you won't be seeing these wires here because we are working on the 3D printing of these glasses so as to enclose everything. So it's a glass that helps the visually impaired through audio feedback using this earpiece. So it all begins with sensing and a camera for facial recognition, object detection, and environment scanning. So the camera scans the environment after you press this first button. It scans the environment and it tells you where you are. Okay, it tells you, oh, there's a dog in front of you. It tells you there's someone standing beside you. Anything the camera can capture. And the second one is for facial recognition. When I'm in front of you, I want to see if I already know you before or if your data have been stored on this microprocessor. Then the third one is for object detection and navigation. So if you, let's say you are in your house and you want to navigate, okay, I'm going to the bathroom and there's an obstacle in front of you. You know, there's not, these ultrasonic sensors are by the sides, not the front. So how will you avoid obstacle in the front of you? You use the camera for that. So now that's where you press this button. It scans what is in front of you, it tells you, and it tells you either to move right, to move left, or to continue going. Then the ultrasonic sensors by the right and left is used for distance measurements. So let's say you are moving and you are closer to an object. It tells you that, oh, you are so centimeter close to this object. Move right, move left. But we are working on making this ultrasonic smaller. Okay. Because as you can see, it's very not
it's too obvious.
Yes. So we are looking at making it. It's a team. Lolade Anjowo, he's a graduate from Bells University now. So we worked on this together. So, and we are still working on it. So we are working on making these ultrasonic sensors smaller and making these glasses compact, 3D printing the parts, and this board, we're not going to be using this anymore.
Okay, so a prototype stage, that's why it looks like this, and it works. So I want to ask, have you tested this on an actual visually impaired person?
Okay, when it comes to testing, we made 3 basic tests. We tested it on someone that is not blind. Okay. But the feedback was the person couldn't really relate with what these glasses does because
you're not blind.
Exactly, you are not blind. And the second one was a partially blind individual. These glasses, it helped, but using it for the first time, it will be strange, you get. But the person said the feedback was that it would be better if the comfortability of this is worked on. So the person complained about the comfort. That was why we thought of,
that's a valid feedback.
Yes. Let's work on the printing of these glasses from scratch. Then the third test was with a totally blind person. It's a prototype, so there are errors. So the person complained about the errors, but the person appreciated what we've done.
I mean, that's why you test. You test to figure things out and to know where to make adjustments. So, what's the way forward with this?
Okay. One of the major problems we're still facing now is finance.
Mm.
Getting a better board that would serve the purpose of what we want Mavic Vision to accomplish. We've reached out to a couple of individuals, a couple of startups, and we are hoping that their response in the next 1 to 2 years, because some of them have promised, but we still need more sponsors and we still need more people to invest in this kind of innovation.
Amazing. So how do you power this? Do you charge it? Does it use solar?
Okay, it uses a Leon battery. It's rechargeable. So you don't have to bother about, oh, it's dead, because it's a lithium battery. It's charged very fast and it can take you the whole day.
Amazing.
To run.
Can I wear this?
Sure, you can.
Okay. Hope it's not for small heads. My head is very big. Can you help me? I don't know how to.
That's for the audio feedback. Okay, something like this. This can be inside. It doesn't necessarily have to be outside.
Okay, so I don't have to hold this.
No, you don't.
Amazing. So with this on my head, can you show me, point to this is what this specifically does? This is what this specifically does.
Okay, so this is meant to be inside here. This is meant to be inside here.
Okay.
Why this comes here? So now you have to hold this button. So this is the button that you use to give this robot a command on what to do.
Okay.
So the first is for facial recognition. Second is for environment scanning. And the third is for obstacle detection. This camera performs that function. So now this is the ultrasonic sensor here for detecting objects from the right. And we didn't want to use a beep system because most of the projects on YouTube, you see that they beep. But this one, it uses a vibration sensor. So any obstacle from the right, the vibration sensor vibrates from the right. Then the left also vibrates from the left. Then this is the audio output. So we have this, and we also have the one on the Raspberry Pi.
Okay.
So anyone you want to use, you might not have an external earpiece that you just want to use the inbuilt earpiece. So that's what that is for.
Fantastic. How about the camera?
This is a Raspberry Pi 4 camera. It's an RGB camera also, and it's used for facial detection using OpenCV, object recognition, and object avoidance to avoid objects. And how the audio feedback works is that we used a text-to-speech model on Python. So whenever this senses, it sends information to the Raspberry using serial communication. Okay. As you can see, we have an Arduino Uno here,
yes,
then a Raspberry. So they communicate using serial communication. So when this signal is sent to this, it plays the text-to-speech that has been stored on this. So object detected from this, a practical video on this, object detected from the right, object, it has been saved.
Okay, there. You have a practical video on this. On amazing, YouTube. Amazing. So what's the battery life? Because I imagine I wouldn't want to be charging this if, if someone that is visually impaired, they want to use it for as long as possible. What's the battery life on this?
Okay, for now, considering this as a prototype, the battery we used was a Leon lithium battery, and it lasts for 24 hours.
Wow, all day.
Yes.
Amazing. Also, for a material, for a gadget like this, have you tested it or have you thought about its performance in different weather environments? For instance, during rain, humid conditions, have you thought about how it will perform and what steps to take?
Okay, weather is one of the things that should be considered when building your robots.
Yes.
So during different seasons, this robot tends to deliver different ways.
Oh.
So that is one of the reasons why we need to enclose the components that needs to be enclosed during the printing. And so there are some sensors that we use. That's the ultrasonic ultrasonic deals with sound waves.
True.
And let's say, okay, you're in a rainy season and water can affect waves. Water can create different kind of wave disruption. So we are planning on using a better sensor that even if it's raining, it can still be able to sense our rights. Sometimes when you work with these components, you see that there are some glitch that happen.
True.
Now, using it in something like Mavic Vision, if that glitch is something that happens at a very crucial moment, let's say you are crossing the road and it didn't measure it accurately, it's no more helping.
Talking about lawsuits here.
Something like that. So
amazing.
We're planning on upgrading the components that are here.
Okay. So finally, I want to ask, what do you need? This is such an amazing idea. It will help so many people, with issues with eyesight. What do you need to make this something that is not just useful, but is also effective?
Okay. What we need, because we are two.
Okay.
We need collaborations. We need people that know these things, people that know way more than we do, people that can say, oh, you have issue in this, I'm into this, I'm into this, and we are open to anybody that wants to collaborate. They said Rome wasn't built in a day, step by step. Okay, if you bring yours, I bring mine, you bring his. Before you know, this is already a full and working product.
Amazing. I love this. This is fantastic.
Thank you very much.
Good luck on your journey.
Yes.
Toby, this is amazing and so useful.
Thank you so much.
Thank you for sticking with us on the Pioneer STEM Show. We'll be right back.
You're welcome back to the Pioneer STEM Show. And if you're just joining us, well, you've missed quite a lot. We had a young guest, Tobiloba Bankole,
yes.
who dazzled us with this eyewear for blind people. It may not be the first of its kind, but the fact that he was able to put it together, he's still developing it, and he's also seeking for collaboration. What do you think generally about Toby's?
I love how it pushes for collaboration.
Yeah.
It pushes for growth. Usually when people come up with solutions, they think that's all to it. But I love how he sees there's a need for skill, there's a need for growth. So it's beautiful to see how he also is using his gifts and his passion to help people that need it.
Absolutely. There's this thing I like to say, empathy is a mother of innovation.
Yes.